This is an introduction to the Altium Desktop NanoBoard NB2DSK01. Welcome to this training module on the Introduction to Desktop NanoBoard NB2DSK01. This training module introduces Altium's Desktop NanoBoard, its daughter boards, and peripheral boards. Altium's Desktop NanoBoard NB2DSK01 is a reconfigurable hardware platform that harnesses the power of today's high-capacity, low-cost programmable devices to allow rapid and interactive implementation and debugging of digital designs. The interchangeable daughter board concept supports a much larger number of I/O connections from the target FPGA to the connected peripherals. With the Desktop NanoBoard NB2DSK01, peripherals available for the daughter board FPGA are delivered on removable peripheral boards, providing a simple and cost-effective method for rapid prototyping of hardware concepts. Here is an overview of the Desktop NanoBoard and various peripheral boards. In the motherboard, there are 3 100-pin connectors used for connecting to the daughter boards, and 3 connectors for the peripheral boards. In addition to external peripherals, the motherboard has a number of standard peripherals, including touchscreen display, 5 push-button switches, and 8 dip switches, status LEDs, 4 analog-to-digital converters and DACs, 36 digital I/O connectors, daughter board reset and test button, 2 JTAG extension ports to communicate with the target system, an SD multimedia card socket, CAN, RS-232, PS2 mouse and keyboard, 2 power sockets for power input and expansion, on-off switches, and so on. There are also other resources such as several memory devices, a programmable board ground, and real-time clock. With a standard peripheral board plugged in, there is access to Ethernet, IRDA, USB slave interface, compact flash, various video inputs and outputs. It is also possible to use the existing peripheral boards as templates for creating customized boards to plug into the NanoBoard environment. Communications between the various devices within the system makes extensive use of the technology defined by IEEE standard 1149.1, commonly referred to as JTAG. The Desktop NanoBoard NB2DSK01 is connected to a PC using either a parallel or USB connection. The NB2DSK01 provides a corresponding parallel port through the use of a 26-pin male header. The USB connection provides high-speed communication. Local to the NB2DSK01 itself, there are multiple JTAG chains present. These chains provide the communication paths between the various devices in the system. Each Desktop NanoBoard NB2DSK01 contains NanoTalk master and slave connectors that allow multiple nanoboards to be daisy-chained together. The hard and soft JTAG chains are passed between boards using a 10-way IDC ribbon cable from the slave connector on the first board to the master connector on the next. Under the management of the NanoTalk controller, these chains are kept continuous, with both chains sent out from and received back by the master NB2DSK01 in the configuration. The master is the one connected to the PC and ultimately the Altium Designer software. As well as chaining multiple Desktop NanoBoards together, it is also possible to attach your own board to the NB2DSK01 through a JTAG connection for inclusion into the system. Up to 2 user boards can be connected to each NanoBoard. No special control circuitry is required on a connected user board. Simply chain the JTAG ports of the compliant devices on your board. Both the physical ports and the soft ports established to connect with the Nexus-enabled devices inside a device, and connect both chains to a 10-way header for connection to the NB2DSK01. The NB2DSK01 contains many digital devices that are highly sensitive to electrostatic discharge. To provide a level of protection against such discharge, the NB2DSK01 incorporates shielding for the following metallic-based components that are routinely handled: the RS-232 port, the CAN port, the USB port, the PS2 keyboard and mouse ports, power toggle switch, and SD card reader. Each of these components is connected to a common shield point. When the NB2DSK01 is connected to a PC using the USB connection, the component shield is essentially tied to the PC's chassis ground, and it is through this ground that any buildup of electrostatic charge will be dissipated. If the NB2DSK01 is not connected via the USB, then the electrostatic charge is coupled via a 10 meg resistor and a 470 picofarad capacitor to logic ground. In addition, ESD, RFI, and EMI and aggressive earth management requirements are achieved through protective shield nets made available to the motherboard, daughter board, and peripheral boards via the mechanical standoffs. A dedicated ESD pad is also provided on the motherboard. The target FPGA devices to which a design can be downloaded reside on separate satellite boards referred to as daughter boards. These boards plug into the NB2DSK01 motherboard. By keeping each programmable device on its own daughter board, engineers can easily change the target project architecture while keeping the NB2DSK01 a truly FPGA vendor-independent development board. Various daughter boards are available, each offering a different FPGA device. A daughter board is mounted onto the NB2DSK01 motherboard by plugging its 3 100-way male connectors into the motherboard's 3 100-way female connectors. In addition to the user-available I/O, the daughter board connectors provide pins for a series of other functions, including implementation of the NanoBoard Communications protocol, power, and programming of the FPGA device. With the desktop NanoBoard NB2DSK01, peripherals available to the daughter board's FPGA are delivered on removable peripheral boards. This provides a simple and cost-effective method for rapid prototyping of the hardware concepts. Peripheral boards reduce congestion on the NB2DSK01 motherboard while allowing additional resources to be made available to the daughter board for expansion of designs. Application-specific plug-in peripheral boards give further flexibility and greatly accelerate the process of exploring design flows in real time. Additionally, peripheral boards continue to be developed by Altium, making it easy to evaluate new and alternate technology options, such as wireless networking. The desktop NanoBoard NB2DSK01 caters for the use of up to 3 peripheral boards and is delivered with 3 such boards as standard. A peripheral board is mounted onto the NanoBoard by plugging its 100-way male docking connector into the motherboard's corresponding 100-way female docking connector, referred to as Nano Connect interface. The board can be securely fixed in place using the available threaded standoffs. When changing peripheral boards, please take care not to damage the connector that attaches the peripheral board to the motherboard.